Hello, geometers, and welcome to our first installment of Virtual Geometry, filming live here from KO8, providing you a little place where you can get some extra practice, a little extra instruction, a little step-by-step explanations to some challenging problems, things like that, just to help us all be as successful as possible. So, to be clear before we get started, when something like this is assigned for homework, my expectations of you guys is just to be following along with me. In your notebooks, make sure you're writing down problems and worked out solutions right along with me, and that's just what will be checked for your homework, okay? So, without further ado, let's get started on our very first topic, a topic that I love, right triangle trigonometry. You might be wondering, what the heck's that? Well, right triangle, pretty obvious. It's a triangle with a right angle in it, okay? Trigonometry is, in general terms, it's the study of triangles. But when you think of trigonometry or trig, the ideas that you should kind of come to mind are these three guys: sine, cosine, and tangent. Okay, and the way that we remember what exactly they are and when we use them is a lovely acronym. Sine is opposite over hypotenuse, so we say so. Cosine is adjacent over hypotenuse, so we say ka. And tangent is opposite over adjacent, so we say toa. So put it all together, we say SohCahToa is how we remember which sides go with what, and this graphic is a nice little demonstration. All right. Well, let's get started when we're going to use these. So I left it kind of a blank sheet to show you how easy it is to really make your own problems if you do in the future want to quiz yourself. So let's make a right triangle like that. It's always got to be a right triangle. Keep that in mind. And I'll put a 61-degree angle here. That's my side X that I want to solve for. And that side's 10. All right. Key thing that I would definitely do if I were you, especially as you start working with these for the first time, write that nice little acronym up in the top corner of your sheet. It's going to help you to refer back to whenever you want, really. So it's pretty nice in that way. All right, let's get started on our first example. Now, the process that I use, this is totally, just the Mr. Crofton type. It's just the way that I do it to try to eliminate any silly mistakes or anything like that. I circle that reference angle, the angle that I'm going to be using. And keep in mind, that reference angle is never going to be your 90-degree angle. It's always one of the acute angles, whether you're solving for it or if it's an angle given to you. Now, the reason why I circle is because it really is very easy once you draw that arrow. You can see that 10 is clearly your opposite side. Cool. So I've got adjacent and hypotenuse. These are the ones that people sometimes get mixed up. But keep in mind, hypotenuse is always opposite the right angle. It's always the longest side. So that makes this our hypotenuse. And then our adjacent leg is this one right here. Adjacent means next to. Leg means one of the sides that makes up the right angle. Therefore, that's my adjacent. Cool. Now, I've got that all identified. First step, key, got it down. Now I got to figure out which two sides out of the three I want to use. I obviously need to use my adjacent leg because that's x. My whole goal is to solve for x, so I need to use one that uses the adjacent leg. So I basically eliminated sine. I know I'm going to use either cosine or tangent. But let's see. The other side I have to use has to be a side that I'm given. It must be a number that I'm given. And hey, there's my 10, and it's my opposite. So noticing my lovely shortcut up here in the corner, I can tell opposite and adjacent. Hey, that's tangent. I'm going to use it. Let's go ahead. Tangent of the angle, which is 61 degrees, equals the opposite side over the adjacent side. Boom. Nice. Got it all set up. I did a lot of the legwork just to get here. From here, you got to know just the process and a basic skill that we've learned a bunch of times, just cross multiplying if you put it over 1. All right, tangent 61 times x. Can't combine them, so it's going to stay as tangent 61 times x equals 10 times 1 is 10. All right. Now, notice I didn't combine these. Tangent 61 is very different from just 61. It is a weird decimal, so I'm just going to leave it as tangent 61 for now. My whole goal is to get x by itself. To get rid of that, I'm going to divide by tangent 61. Boom. Keep in mind, whenever there's an equal sign, you got to do the same thing on both sides always. So I'm left with just x on the left and 10 over tangent 61 on the other side. So, anyone want to do that in their head? Didn't think so. So, we need a calculator. You need a calculator for this. This is not mental math kind of stuff. You're going to do 10 divided by tangent 61. Close the parenthesis and see what we get. I did close the parenthesis, but it's all good. That works anyways. We got 5.543. I like rounding to the nearest thousandth because it's very exact. It gives me as close to the exact answer as possible. I'm just, a little nitpicky like that. So anyways, boom. Got the first one done. Let's do another quick example. I'm going to do this one a little quicker. So again, feel free to pause, rewind, do whatever you want as I go through it. Let's start that one over again. So keep in mind, always got to be a right triangle. Good. I'm going to make this angle here 46 degrees. I'm going to make this side x and make this side 30. How about that? A lovely, lovely right triangle. Now let's make the screen bigger again so I can get in there. Cool. All right. Now, follow the same process again. Circle the angle of reference. Use that to identify your opposite side. Then I know that my hypotenuse is opposite the right angle, and my adjacent leg is the leg right next to the angle. Beautiful. Now, I got to pick which tool. I need to find x, so I definitely want to use the adjacent leg, and I need to use another side that's given to me, so I want to use the 30 here as the hypotenuse. When I look through my rules, which one uses adjacent to hypotenuse? That's my cosine. Okay, so let's go. Cosine of 46 degrees equals, let's see, adjacent is x over hypotenuse, which is 30. Awesome, I went through all that stuff to get this problem set up for myself. Now, put it over 1 and cross multiply, just like we've always done. 30 times cosine of 46 equals x times 1 is x. And look at that little present I just got. X is already by itself, so I am golden. I'm looking good. I just got to go to my calculator and plug in. Let's see. 30 times cosine 46. Enter. And there's my answer. Okay? Now, one thing, be careful. Rounding, rounding, rounding. If I'm going to the nearest thousandth again, that's 3 decimals in, but notice the 4th decimal is a 7. In other words, the 10,000th place. That 7 bumps the 9 up to 10, basically, which bumps that 3 up to a 4. So rounded to the nearest thousandth, this is going to be 20.840. All right. And that, my friends, is some right triangle trig solving for side lengths. Okay. Now that we've done these two examples together, I'm going to give you a couple examples to try. All right. Now, I'm not going to work these out step by step, but at this point, pause it, copy them onto your notebooks, try them out yourself. And if you've tried them out, you should have gotten these answers. All right. So let's move on. By the way, you should have used sine in that first one and cosine in the other. So identifying that tool, obviously a very important part. And what's even more important, obviously, is a geometry joke, of course. So why didn't sine or tangent go to the party? Just cuz? Oh, just cuz? Oh, that's so funny. That's great. All right. Well, let's move on then. Quick little bit here, very related, very similar to what we just did, is inverse trig. It's the same idea, only difference. Inverse trig is used when finding angles. What we did was we used that right triangle trig stuff to find sides. Inverse is used to find the angles. And you got to remember a really important acronym for it. the same exact one that we've been using. SohCahToa is the same thing that you use for inverse trig. You're just going to put a little twist on it that I'm going to show you really quick and then give you a couple more examples, and we are good. So, solving for angle measures. Again, I can make any problem I really want to here. Let's make it like this. Another right triangle, of course. This side's 23. This side is 19. This is my unknown angle that I would like to find. Okay? Notice there's no x there because there's no side missing. I wrote theta because that's how we identify unknown angles or angles of reference. Okay? Same exact process. So, let's go for it. Why not? SohCahToa. Hard writing and talking at the same time. Anyways, got my shortcuts written up here. I gotta identify which one to use. Circle that angle of reference. Notice it's not a given angle this time, but it is my angle that I need to find, so I gotta use that. Opposite side, adjacent side, and hypotenuse. Now the one difference here is you have to identify two sides that are given to you and use those two because your angle is your unknown. So I noticed that's these two right here. Adjacent hypotenuse, hey, we're going back to cosine again. Nice. So the way I set this up is I write cosine of theta equals my adjacent, which is 19, over hypotenuse, which is 23. Now, you might be looking at this and saying, okay, I guess we, divide by cosine? No, 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 no. This is something called the inverse, and this is what we use to undo that trig function. When I write cosine inverse, I'm taking cosine inverse of that left side. It cancels that out, and I'm left with just that theta, okay? But keep in mind, with an equation, you always have to do the same thing to both sides. So, what I'm left with here is theta equals cosine inverse of 19 over 23. Last step, let's see how we plug it into our calculator. All right, pull it up. Let's clear that other junk away. I want cosine inverse, so I hit second cosine. Now, your calculator might be a little different, but you want to look for that -1 above your trig functions. And then type in 19 divided by 23, close parenthesis, make sure you do that, enter. And we've got an answer. Look at that. These ones are nice and easy and generally pretty quick. You should get 34.301. Is that what it said? Yes, 301 rounded to the nearest thousandth. Keep in mind that is in terms of degrees because you just found the angle measure. Cool. So, a couple more examples for you to try out here. Again, pause it, take a minute to write them down. I'll reveal your answers when you're done. All right, and these are your answers. Check them out, see how you did, and guess what, guys? That concludes our very last, oh, this should be a theta, though, and this should be a theta. Sorry. That concludes our very last edition, our very first edition of Virtual Geometry. I hope you guys learned a little something, got a little practice, and helped you out. I'll see you in class.